Alright, part 2. In this video, I will be talking about centrifugal forces. I will mainly be dealing with vertical circles. The first thing I want to go over is acceleration, or how acceleration works for circular motion. So, in linear motion, you learned that velocity and acceleration, if pointing in the same direction, the object is speeding. If velocity and acceleration are pointing in different directions, then the object is slowing. And if the velocity is constant, then acceleration is 0. But this is linear. Now, we will build up on this and talk about how this all comes into play when we're dealing with circular motion. So if you have a circle, you know that the object goes at a constant velocity. It needs to go in a constant velocity because that's how it will maintain the velocity. Because if you go at, like, say 4 meters right here, or 4 meters per second, and go at 1 meters per second here, and go at, like, say 2 here, go back to half a meter here, it's not consistent. So in order to maintain circular motion, you have to maintain you have to maintain the same speed. And in linear motion, you learned that if you have the same speed, or same velocity, I should say, if you have the same velocity, then you know that acceleration is 0 and does not exist. But that's not the case in circular motion. In circular motion, even though the velocity or speed is the same, its velocity being vector, or velocity being a vector quantity, has a magnitude and a direction. So it has a mag, short for magnitude, and direction. The magnitude stays the same here in order to maintain circular motion. But when it comes to direction, there is no specific direction. True, there could be instantaneous velocity in one certain spot. That could be a velocity, say 4 meters per second to the east. Seems east, so let's just say east. That's instantaneous velocity. But that's just for one point. In a circle, the velocity continuously keeps changing its direction. And in velocity, regardless if the magnitude changes or the direction changes or both change, the object will have acceleration. In our case, since the direction keeps changing regardless, there is acceleration in a circle. And this is how there is acceleration. I hope I'm not confusing you guys. I'll put it this way. Because velocity keeps changing its direction, it's hard to quantify a velocity that acts in a circle. You can't say that a ball moving this way, well, yes, you can. A ball moving that way can be said to have velocity, but this is instantaneous velocity right here. When the ball keeps moving and changing directions, there is no way to say that it has a velocity, because there's no set direction. It's hard to quantify. So you can't say that there is a velocity. But because the direction keeps changing, we can say that the acceleration exists. And that's how uniform circular motion works. And that's how it exists. And that is also why there is no velocity or centripetal velocity for circular motion. Okay, so now we're going to get into the formulas. Centripetal acceleration equals v squared, or linear velocity squared. That is the instantaneous quantity we talked about, and divided by the radius of the circle. That will give you the acceleration that you need. And suppose you increase the velocity 2 times, 2v. By how much would the acceleration increase? So if you substitute 2v into this v, we get 2v squared, which is 4v, right? So it increases 4-fold. What if we increase the radius? Say we increase that by 3. The whole acceleration, or centripetal acceleration, becomes it decreases by 1/3. And yeah, the greatest acceleration can be achieved by the greatest acceleration is with greatest velocity and smallest radius. Because if say we have half, that just becomes 2, or that just multiplies by 2, right? Because since half is at the bottom, we flip it because you're dividing, and that multiplies with this. So either way, the velocity will be increasing, and in this case it will be increasing 2 times. So that's how it is. Alright, what is centripetal force? Centripetal force is basically the force that aids an object in maintaining a circular path of motion. Now what does that mean? Well, this may be a very, very small definition, but it takes a lot to understand. Let's see. So for example, we have a yo-yo, right? So we're just suppose we say you're doing the around the world with the yo-yo. That's where the yo-yo goes in a circle like that. Right? You're doing that. And so the centripetal force is what is drawing the ball in all aspects, regardless of its position wherever it is, towards the center. In all of these aspects, it's going towards the center. So this, whatever force is drawing these towards the center, is the centripetal force. My bad, I stuttered back there. Okay. So in our case, since the yo-yo is attached to a string, the centripetal force is the force tension. And that's centripetal force in a nutshell. It's whatever is drawing the force towards the center. And this, whatever the force that is drawing the object towards the center, is the positive direction in a circular path. Like, for instance, right here, force normal, wait, no, the force normal doesn't exist. Okay, if the yo-yo is back here, tension is pointing that way, it's positive. But weight force is going downward. Weight force is downward, so that would be negative.